So today I'm going to be talking to you about how you can enable real-time data processing for AI in Python and why would you even want to bring real-time to AI applications. So let's get started. So we've seen this concept of streaming for AI applications where the motivation is, within batch processing, we'll be running a batch once an hour, once every 2 hours, once a day, et cetera. But there's a delay between fresh data and the insights. So the idea of bringing streaming in AI applications is particularly important around this context where acting on data as it arrives is of particular importance. Example of this includes reacting to data coming from IoT devices, anything to do, for example, with air quality data. Another example is in shipping, for instance, where you might set up some sensors for ships to track their speed or velocity, fuel consumption, and this may later be used for reporting for the appropriate regulatory body. Other examples, of course, include social media, where there's a constant stream of information being returned by the users, and we might want to act on that information. Now, with the introduction of LLMs, we can now think about this also in the context of RAG systems, where I might have an LLM connected to some kind of database, and this database is being updated in real time. And this enables me to gain insights and interact with the LLM using data that is fresh. This can be used for things like reports, warnings, or some kind of report or action system that relies on getting fresh data for its use case. Some of the challenges in real-time data processing, of course, is, typically most companies nowadays don't necessarily involve streaming. They typically will deal with traditional batch processing, which can sometimes mean there's a lag in between the latest data and what the data that is being processed for reports. The other challenge, of course, is building in-house connectors and pipelines can be time-intensive and error-prone, particularly if we've built an architecture that assumes batch processing. Making a jump from batch to streaming can be quite a significant hurdle for some. And of course, there's a need for scalable, streamlined, and reusable solutions. In particular, we want to make sure that not only are we getting the data reliably, but we can also scale to more complex projects as needed. So today I'm going to talk to you about what we do at Bytewax and how you can leverage the Python ecosystem, as you know, with Bytewax to bring streaming, microbatching, and batching using all the same language. So we are a Python native framework for real-time stream processing. We are open source, and the way Bytewax is built is it uses the package Timely, built using Rust in the background, and it has a Python API exposed, which enables you to leverage the speed of Rust with the ease of Python. And we're very proud to share that recently we reached over 500,000 downloads on PyPy. So we've reached a very significant milestone, and this represents the trust that many developers have placed in us. So we continue to develop and produce more modules that are of use. And the way it typically works is it's fairly easy to install. We can do it via pip install Bytewax. What enables us to use Rust in the background with our Python API is a Pyo3 package. So we're using Pyo3 as well. And typically the way we work is Bytewax is a directed acyclic graph framework. Namely, I have some kind of input. I connect my operators as steps or nodes in the DAG, and then I have some kind of output. So in this particular example, I am making a connection to Kafka through the use of the Kafka operator. These operators are modular standalone steps. You can think of these as nodes in the DAG where my input is going to be some kind of data source. In this case, I might be listening to Kafka topics. I'll have some kind of output sync. In this case, I will be outputting to Kafka as well through the use of the out topic, but we can switch, we can swap the use of these operators. My operator or my output can be anything from the terminal to any other application. So this is where this idea of the connectors is introduced, where our goal or the way we envision things is we have the connectors as the link between real-time data sources and AI pipelines. The connector can be a data source such as Kafka. It can also be IoT devices. It can be classic databases. We then have an AI pipeline. In this case, this is going to be a Bytewax data flow with different operators. And then we can use the sync connector to send the process data to either a database, an AI model, or any kind of analytic tool. So this is more or less the framework or assumptions that we're following at Bytewax. Our latest offering is we're very excited to share connectors, operators, and sync, where the idea is to have each of these as modular offerings where you can plug and play with different providers, build a Bytewax data flow to transform the data, and then use another connector to store the results as you need. So typically the way that the data flow would look like is would have some kind of input source. As I mentioned before, it can be IoT data, it can be coming from an application, it can be a database. We can use connectors, and each of these connectors is going to be a modular standalone installable module that acts as an interface between Python and the data source that you're using. And from here, we can transform the data through the use of the Bytewax data flow. As I mentioned, Bytewax offers this as an open source package where we're using DAGs to transform the data. We're currently offering these connectors as either open source operators or premium operators. We offer a platform for scaling. And then once the data has been transformed, we can return it or save it through the use of a connector either to an application, a database, etc. So that's enough for the spiel. I want to tell you a little bit more about the connectors. So each of these connectors can be installed as a separate module through pip. We have both open source, commercial, and premium licensing options, and we're currently offering support through Slack and documentation. Today, I'm going to have a chance to demo to you an Azure AI Search connector. This connector is specifically geared towards the process of building retrieval augmented generation systems, where the goal is to transform text into vectors and store the vectors onto a database. In this case, what we've done is we've developed a custom sync for Azure AI Search vector database for real-time data indexing. The way this works is, as I mentioned, the goal for each of these modules is for it to be a standalone module. So you can install it, we can import it, we can define the schema, and then this small data flow right here is reading a data source. It's applying some kind of function. In this case, this is just serializing the content of a JSON line file. And then it's applying function to apply the embedding and then store the output onto Azure AI. So in this case, the output is returning the vectors onto the sync. Towards the end, we'll have a chance to see what this looks like. But the idea is for a number of different data sources, we can sort of plug and play and change the output. So if you're not working with something like Azure AI, but you're working with something like Weaviate, for example, you can plug and play that as an output sync. So let's take a little bit about some real-time AI use cases with Bytewax. So we have as an example streaming data from IoT sensors for predictive maintenance. Again, if I'm thinking about something like a ship or any vehicles that have sensors in it, we can have the sensors detect if there's some kind of malfunction. The sensor can then send a signal for it to have some predictive maintenance done on it. And we can even do some data science on it to analyze whether there's further issues or what's causing the problems in the first place. Other examples, of course, include real-time recommendation systems in e-commerce. When we're handling data from customers, it's better to have as much data and data as up-to-date as possible. So if we wanted to recommend products to customers, we could use real-time data, not just from that customer, but also aggregate data from what other customers are purchasing in real time. We can also incorporate adaptive machine learning with feedback loops. If you want your model to be refreshed or updated as you go, and you want to handle the problem of data or model drifting, this is one other scenario where real-time and streaming comes in very, very handy. And the purpose for us as an open source package is to provide developers with modular extensible connectors to construct these workflows. So here's an example of a RAG workflow that we can build using Bytewax and leveraging the Python ecosystem. So this particular system is built in the context of financial data. And within financial data, typically we can have two types of data. We can have structured data, such as tables or prices for the stock market. But we can also have unstructured data in the form of news articles, discussions on forums, blog pieces, opinion pieces, etc. And both of those types of informations can change in real time. Every single day I have new stock market prices. Every single day I might have somebody writing on Reddit an opinion on a news article, etc. So this specific system leverages both the connectors and the modularity to take that unstructured information, transform it into vector, and store it into a vector database. In this specific case, this is on Azure AI Search. And so the key steps in here can be broken down into different pipelines. We have data extraction, where we can extract information from PDFs, internet, stock market prices. We can do some data wrangling and preprocessing. If we wanted to make this real time, we could store all this information into Kafka as topics and open up a Kafka instance through the use of our connectors. And then from here, we can build a pipeline to perform indexing, where I will take that text, I will chunk it, I will clean it, I will chunk it, I will apply some kind of embedding model, and I can then store the data onto an Azure AI Search instance or any other vector database. If I want to complete the RAG system, of course, I can then set up retrieval from the vector DB, and then I can incorporate the generation of an LLM to generate some kind of response. So in this specific application, I would have a real-time report that may recommend to someone what stocks to buy, or that may recommend to someone, these are the stocks that are currently being purchased or sold, or there's some kind of scandal or crisis around this particular stock, so beware. In terms of where the connectors come in, so this one right here can be built as a Bytewax data flow, and we can use the Kafka connector to listen to these topics. This enables us to build an entire system using Python in real time. We can later on build a Bytewax data flow to generate the vectors in real time, and then we can plug another connector, in this case Azure AI Search, to complete the system. So what we envision is being able to allowing the users to build these kinds of pipelines through plug and play, so they can choose the different data source and different data output that they wish to use. So the resulting connector in this particular case is the Azure AI Search, but we're currently offering a number of different connectors. I'll provide a list to all the connectors that we're currently supporting towards the end. And as I mentioned before, the idea behind this is that we're able to pip install each of these as a standalone module, import it, configure it, and then use it. So let's go take a look at a brief demo. So in here, I have a Bytewax data flow. And this Bytewax data flow is in charge of indexing. And my goal is going to be to come here where I have a Azure AI Search instance. I'm going to create an index, and I'm going to populate the index using streaming. Now, the advantage of Bytewax, of course, is that it supports both batch and streaming options. So if you're currently working with batches as opposed to real-time data, we support both. So I'm going to show you the batch version today. So in here, I am importing my Azure AI Search sync. I am importing my data flow object, which is just a DAG for the steps that are going to include reading the data, transforming it through the operators, and then storing the data onto the sync. And then what I have here is just some configuration of my credentials. In this case, I had to create a number of different services on Azure AI. So what I've done in this case is I created an Azure Search endpoint. I'm also going to be using the Azure embedding deployment. So in this case, I created a number of different resources on the Azure portal to make sure that I can complete the entire indexing workflow, where I will chunk the data, I will embed the data, and I will store the data onto the database. I can initialize my client. I have a function to generate the embeddings. And what's quite neat about the way Bytewax operators works is we define a function, and then we can apply or map the function as a map operator. So in this case, what I've done here is I have a list of news. What I've done in here is I've created a little dummy data set, but we can make the data set much more complex. So in this case, the news is just defined as a data class that has an ID. It has a category, whether it's a news, review, or social, and then some text. As I mentioned, the data set is just a dummy one, but we're collecting ID, category, and text. And we have 3 types of categories. We have news, we have review, and we have social media post. So here's my simple data set. And then in here, I have my data flow. So I initialize the data flow. I set up my first step in the DAG, which is just the input operator. And I'm just using the news event entries, which is just a bunch of data classes that I defined to have an ID, a category, and a text. I can then use the map operator on the news events, where what's going to happen is my function right here, which is in charge of embedding, is going to apply the Azure AI search embedding model onto the text field. I apply my embedding, and then in here, I define my schema. So in this case, I want the schema to contain the ID, the category, the text, and I am adding a new field called vector. I can then initialize my Azure AI search sync, and I can run the embedding. So let's go ahead and do this. I've created a couple scripts. The first one is connection. Connection.py is simply going to create the index. So if I come back here and refresh, I now have an index created. And if I search for it right now, it's empty. So I am now going to go ahead and run my data flow. So I can execute these data flows through the command python-m bytewax.run dataflow flow. Dataflow is the name of the file. So in this case, it is now executing the embeddings. So let's go and take a look again. If I hit search, I now have here the search store, the ID, the category, the text, and the vector. And so going back here for a little bit, so for our future work, what we're hoping to do is to add as many connectors for diverse AI and ML tools as possible. We want to provide enhanced support for edge to cloud data flows. And in particular, part of what's next for us is, now that we have the modules, now our future work involves this idea of end-to-end data flows, where we can provide blueprints for creating workflows that typically require the same steps. If I think about indexing as an example, it's always the same steps. I clean my text, I chunk my text, I apply an embedding, and I store the embedding. So providing these kinds of blueprints as an end-to-end data flow is also one of our next workflow. Let's just go back here. If you want to check all of the connectors that we're currently offering, you can check us out on bytewax.io. So if I go bytewax.io and you visit our blog, our latest blog has the entire list of modules that we're currently supporting. And at this point, the list is quite extensive. We support anything from Apache Kafka, Google BigQuery, HopsWorks. There's a huge list. So what I recommend is that you come check us out. Each of these is going to be installed in a similar way as to what I showed you, and we're following the same framework as I showed, where we plug and play and we incorporate these connectors through the use of the modules. That's it for me today.